In this section, we're going to go over cloud identification and cloud reporting. It's going to involve looking at the difference between tornadoes and funnel clouds, shelf clouds and roll clouds, wall clouds, and then finally we'll end with scud or lookalike clouds, which could trip you up in identification. One common theme to look for through all of this cloud identification will be context. Is what you're identifying make sense in the larger picture? Is what you're seeing make sense in terms of what's surrounding that feature? And then, do you see rotation? That'll be a common question we'll ask. Is there evidence of rotation touching the ground? Is there any debris observed? And is the cloud sloping towards or away from the rain? This will be important as we get into the shelf clouds versus roll clouds. And the first cloud we're going to look at in the cloud identification section is the shelf cloud. Shelf clouds are horizontal shelf-like clouds on the leading edge of a thunderstorm. A characteristic of shelf clouds is they usually extend over the entire horizon, and shelf clouds signal the approach of gusty winds, possible hail, and heavy rain. Going back to our conceptual model of the squall line, a common place where you may find a shelf cloud, remember back when we looked at the squall line, we had very strong upward motion in close proximity to the strong downdraft just behind that updraft. And this kind of close proximity of the updraft and downdraft are what creates that pinwheel effect or that rotor effect where you get that shelf cloud appearance. And you'll see these shelf clouds usually if you're east of a squall line looking back to the west as it's approaching. That's a common area where you would see the shelf cloud. Now if we go back to our conceptual model of the supercell, the shelf cloud is typically going to be found on the north side of a storm here if we're looking back to the west at the supercell. This is where you have your rain-cooled air and your downdraft located, and the shelf cloud is usually going to be located in association with that downdraft rain-cooled air and the leading edge of your gusty wind threat. To understand how a shelf cloud is formed, we can look at the updrafts and downdrafts, and the red here is the updraft at the leading edge of the cloud, immediately followed right behind that shelf cloud with the downdraft. So it's this close proximity of your updraft and downdraft that creates that rotation about a horizontal axis. Now as this shelf cloud moves overhead, you may look up and see very turbulent motion or even some rotation, but chances are in this type of setup your rotation is going to be about a horizontal axis, not a vertical axis that we look for in terms of a tornado potential. There are times where that shelf cloud could become detached from the parent thunderstorm, and this is when we transition to what we call a roll cloud instead of a shelf cloud. Now the roll cloud and shelf cloud pretty much describe the same thing going. You have that rotation about a horizontal axis, and as it passes over indicating the main threat of damaging winds or gusty winds, not really a tornado threat, more of a wind threat. And so the general idea is the same. The only difference here is the cloud is detached from the parent thunderstorm, making it a roll cloud. But whether we're talking about roll clouds or shelf clouds, think gusty wind threat. And here's another example of a roll cloud, again indicating that it's detached from the parent cloud again. And as that roll cloud passes overhead, that's indicative of the leading edge of downdraft outflow and the beginning of your wind threat. Now one clue we recommend to identify shelf clouds is to evaluate how is that cloud oriented with respect to the rain. If the cloud is slanted away from the rain, that's most likely telling you you're dealing with a shelf cloud. Now, do you need to report shelf clouds to the Weather Service? No, you do not need to report shelf clouds, but it's important to know what you're looking at because that'll clue you in as to what threat or hazard to expect. Again, if we see these shelf clouds or roll clouds, gusty winds or damaging winds is going to be the main threat as they pass overhead. One thing to keep in mind with shelf clouds, or really with any cloud in this cloud identification, is perspective. In this example here, we're looking at a shelf cloud more from the side, where it could look ominous to you that this cloud is possibly very low to the ground. But if we were to look more from the front of this cloud, you would see that expanse over the whole horizon, more indicative of a shelf cloud. So just remember that your perspective of the cloud is important. In a similar fashion here, just be also aware of obstacles, in this case buildings, blocking your view from the base of the cloud. And we really can't see what's happening near the ground in this picture. It may look ominous that this cloud is very low hanging, but this is another example of a shelf cloud. And if you were to remove that building, you would see that there was no indication of rotation or any debris near the ground. It's just another example of a shelf cloud. And finally, here's a more classic view of a shelf cloud. Again, just look for that expanse over the entire horizon. That'll kind of tell you that you're dealing with mainly a wind threat and a shelf cloud. Here's a shelf cloud that we will speed up in time-lapse form as it approaches us in this video. And you can get a sense as to the turbulent motions we were talking about as this cloud approaches, which can look very ominous. You maybe see some rotation about a horizontal axis. And as soon as that moves overhead, you get the gusty winds develop. The next cloud we're going to look at is the wall cloud. A wall cloud is a rotating lowering from a thunderstorm updraft base, indicating a strong updraft. Again, you have a broader area of updraft, but where your updraft is the absolute strongest is where you get this isolated lowering of that rain-free base. This is the wall cloud. Now, the wall cloud is important because it indicates your strongest updraft, and that strong updraft is what is really needed to form tornadoes. And often these wall clouds will precede a funnel cloud or a tornado. If you remember when we discussed shelf clouds, that cloud sloped away from the rain. With wall clouds, as we see in this example, your cloud slopes toward the rainfall. Here we're looking to the west, and you see your wall cloud sloping toward the rain to the north here. And we can kind of put in where that downdraft rain-cooled air is. You kind of get this rain-cooled downdraft. It eventually gets ingested into this updraft, and that's why you have the appearance of that wall cloud sloping towards the rain. And another example here, we're looking back to the east, so your rain-cooled downdraft is actually to the south in this picture, but you can see how this wall cloud, and you're indicating your strong updraft, that cloud is actually sloping towards the rainfall in this picture, similar to the last example, indicating a wall cloud. Here we're looking at a time lapse of a wall cloud forming, starting with a broad rain-free base to begin with here. Again, we're looking to the west of this storm, so to the north is your rain-cooled air, and your updraft kind of to the left in this picture to the south. And your strongest updraft begins to be identified by your wall cloud forming. You can start to see we're beginning to form this wall cloud in the middle of the picture. You start to see some of that downdraft rain-cooled air starts to get ingested into that updraft. You can start to see this cloud form on the right side of the picture. So where we have this wall cloud forming, you can see that this cloud is sloping towards the rainfall. And as we pointed out in the previous examples, that's indicative of a wall cloud sloping towards the rain. This video is not in time-lapse form. This is actually real time of the video of the person who took this here. They're a little too close for safety, but this is an example of a rotating wall cloud. We're zoomed in a little close, so it's hard to see the lowering from the rain-free base, but this is something we'd like you to report if you see rotation with the wall cloud. We'd like you to identify that in your report, a rotating wall cloud. And since this is a tornadic threat, funnels and tornadoes can develop from these wall clouds, you want to be looking at the base of this cloud for any evidence of any debris being kicked up, just to double check to make sure there's not rotation being identified at the ground that would transition this feature to a tornado. So to sum up our previous sections on wall clouds and shelf clouds, just remember the key point here that wall clouds are associated with strong updrafts, and that's important because tornadoes feed off that updraft, whereas shelf clouds are more associated with that rain-cooled downdraft, and your tornado threat really much lower to non-existent with shelf clouds because downdrafts are dominating that cloud. And again, with shelf clouds, there's no need to call those in, but just be aware of the wind potential with those. But with wall clouds, we would like you to call in rotating wall clouds to us, just because those can lead to funnel clouds or tornadoes. So just remember that, summarizing things up, wall cloud, updraft, tornado potential, shelf cloud, downdraft, gusty wind potential. Now, unfortunately, in our part of the country, some of these features in these cloud identifications we've just talked about with wall clouds and shelf clouds, they're not always as clear as some of the examples we've shown. So if you're not sure, feel free to take a picture or a video and send it to us on social media. We would really appreciate that, and we can kind of pair that with what we're seeing on radar and come up with an overall assessment as to what you're seeing. Now we want to take some time to go over tornadoes and funnel clouds. Both of tornadoes and funnel clouds are violently rotating columns of air, but just remember the distinguishing factor here is tornadoes are in contact with the ground, whereas funnel clouds are not in contact with the ground. And we've mentioned this a few times, but it's always important to look below the feature you're looking at towards the ground. And we may see this rotation a lot, but just remember to look below that toward the ground for any evidence of rotation at the surface or debris being kicked up that would transition a funnel cloud to a tornado. You may not always see evidence of a cloud or a condensation funnel at the ground. That's why it's important to look for any hints of any debris being kicked up. And just remember, unlike shelf clouds where we saw that rotation about a horizontal axis, not indicating much of a tornado threat, with tornado and funnel clouds we're dealing with rotation about a vertical axis. Now with tornadoes and funnel clouds, one thing that will help you pick out rotation that will lead you toward a tornado or funnel cloud identification is a lot of times these clouds will have smooth edges. And these smooth edges are indicative of rapid rotation. So that would kind of steer you towards a tornado or a funnel cloud, and then whether that was in contact with the ground would be your distinguishing factor between tornadoes and funnels. Here's another example of a tornado here, kind of poor resolution, but you can see in this tornado you have evidence of this circulation in contact with the ground indicating a tornado. And just notice the smooth edges to this feature indicating that rapid rotation. Another example from the Nebraska tornado here. Kind of difficult to tell in this case whether there's evidence of that circulation at the ground, but definitely at least a funnel cloud here with that rapid rotation, very smooth edges to the clouds you can see in this picture. In this picture, while you can't actually see the ground and have visual evidence of that circulation at the ground, this was a tornado, but you can see that evidence of the strong circulation with the very smooth edges to the clouds here. And always, as we talked about with wall clouds and shelf clouds, if you're not sure, just take a picture and we can kind of pair that up with what we're seeing on radar. And you can post your picture or video onto social media, and that's something we would definitely appreciate in real time. Now we talked about, you can email these photos to us, but when we talk about tornadoes and funnel clouds, it's probably better to either call us or post on social media, just so we see it immediately, because that threat with the tornado will be more immediate, and getting that information to us in a timely manner is much more important when talking about tornadoes and funnel clouds. This video was received from a spotter during the August 24th, 2016 event near Monroe, Indiana. We received a lot of pictures and video from spotters, which we very much appreciate, but we want to reiterate your safety is your #1 priority. And in this case, this spotter was very close to the wall cloud. You can see some rotating clouds here at the top of the picture. This was a very dangerous part of the storm. This person was probably too close to be filming. Your priority at this point should be to take cover. And we'll just let this video play out as you can see how rapidly the situation deteriorated, and evidence of a tornado developing occurred very quickly here, putting this person in a great amount of danger. So we just want to repeat that while we do appreciate your reports in terms of pictures and video, just keep your safety as the #1 priority. And there you can see the first tornado, evidence of a tornado form, and then toward the end here you'll see another evidence of a circulation at the ground that caused this spotter to eventually finally be able to convince to take safety. And the last cloud that we're going to talk about is scud cloud, which really stands for stratocumulus under deck. Now scud clouds look ragged, they can look turbulent at times and very ominous. And unlike what we saw with funnel clouds and tornadoes when they had that smooth appearance, these will look more ragged looking, and they won't have the evidence of rotation. They can move up and down very quickly, indicating that turbulence. But what you want to do is lock onto these features over a period of a couple of minutes just to see if there's any evidence of rotation, which you won't see with these scud clouds, even though you can have that up and down motion. And here's some examples of scud clouds. You can see they look like they're very low to the ground, but if you lock onto these features through time, which we would see more in a video sense, you won't see any evidence of rotation with this cloud. Again, they can look ragged, and versus the smooth appearance we saw with the funnel cloud and tornado. And here's kind of a very common type of cloud we would see in this area. You know, some people may be alarmed that you have some low hanging clouds in this case, but again, just lock onto these features over time and you'll see that there's no evidence of rotation, and they usually won't be very long lasting. They'll form and dissipate quickly and may move up or down, but really no evidence of rotation. Here's another very low hanging cloud, very close to the ground, but again, if we had video, you would see that there was no evidence of any rotation, and it has that more ragged appearance versus the smooth appearance. And finally, this one looks especially ominous. You really can't see the actual ground here. We're kind of blocked by some trees. But again, look for context. We really don't have any discernible wall cloud in this feature, so we really that tornado potential is really lower. And again, if this picture was in motion, you wouldn't see any evidence of rotation in this picture here. We're now going to play for you a video of a scud cloud. Just notice in this video how there's no evidence of any sustained rotation. You may have some up and down movements in the cloud, but no persistent rotation. They're very ragged looking, and it's really not associated with any wall cloud or lowering of that rain-free base. That context we talked about, it's really all on its own, indicating scud cloud.